Okay, so in this lesson, we're going to go through some properties of combinations. Now, I remind you that whenever you're selecting objects without order out of a total number of objects, this is where we use combinations. For example, if we have n objects in total, out of which we are choosing or selecting p objects, and that's without order, then the total number of ways we could be selecting these p objects are called combinations. So the combination of p out of n is in fact defined by this formula, which is n factorial over p factorial into n minus p factorial. So where n factorial is the factorial of the total number of objects we have, p factorial, which is the factorial of the number of selections we're doing, and n minus p factorial is the difference between the total number of objects and the number of selections. Okay, now let's just move to the properties of combinations. So first, we have that the combination of 0 out of n is equal to the combination of n out of n, which is equals to 1. So it's as if we're saying that if we're not selecting any object out of our total number of objects, that would in fact be one possibility, which is the same as selecting all objects out of the total number of objects that we have, which is also one possibility. And I can in fact give an example to that by considering if I, for example, walk into a classroom of 10 students. If I choose to take the 10 students with me to help me whatever pick up boxes, in that case, I would be leaving with one group. I have one possibility, exactly one possibility of a group to take with me if I were to choose all of them, because don't forget that combinations do not involve order. So choosing 10 students out of 10 would in fact leave me with one possibility, exactly one group I leave with, which is the same as not choosing any of them. So by in fact not choosing any of them, so that would in fact be one possibility. So whatever the total number of objects is, if the number of selections I'm doing is 0 or equal to the total number of objects, in that case the combination is equal to 1. Now over here, the combination of 1 out of n is equal to the combination of n minus 1 out of n, which is equals to n. So if the total number of selections is 1 or 1 less than the total number of objects, then I would have n possibilities. And that in fact makes sense, because if I go back to the example of walking into my classroom to choose students to just help me go help me pick up boxes. So if I had 10 students in the classroom and I walk in to choose one student, how many students could possibly leave with me, or how many students could I possibly choose if I were to choose one student? Then I would have 10 possibilities. So C1 out of n is in fact equals to n. However, if I'm choosing 9 out of the 10 students, if I'm choosing one less than the total number of objects, if out of the 10 students I wish to choose 9, now that would be equivalent to not choosing one student. So in how many ways can I leave one student out of the selections? That's also n, because I have 10 students in the classroom, then I have 10 possible ways I can leave one student out of the selections. So this is why the combination of 9 out of 10 would also be 10. Now, if we move to the third property, which in fact generalizes a bit the second property. So the second property is just a particular case of the first one, of the second one, where P is equal to 1 for property number 2. So over here, we have the combination of n of P out of n. They're saying it's equal to the combination of n minus P out of n, which if you'd notice that n minus p is in fact the difference of the total number of objects and the number of selections. So for example, over here we have the combination of 3 out of 5. Now the combination of 3 out of 5, the difference between 5 and 3 is 2. So the combination of 3 out of 5 is basically equal to the combination of 2 out of 5, and we could in fact confirm this on our calculator. So over here, if we go to options, proba, so that's 5C3, that's a 10, and 5C2, that's also a 10, and that works for all p smaller than n. So we could in fact prove this. So this is over here for part 3. So we have the combination of p out of n is in fact n factorial over p factorial into n minus p factorial. However, the combination of n minus p out of n would in fact be n factorial over the number of selections, which is n minus p factorial, times the difference of the number of selections and the total number of objects. So that would be n into n minus p factorial. So over here, if we were to simplify this, that's n factorial over n minus p factorial times n minus n. If we were to expand here, n minus n, they cancel out, and n times negative p, that's a p. So which you'd notice we're back to the combination of p out of n. However, for the fourth property, we have that the combination of p out of n is in fact equals to the combination of p out of n minus 1 plus the combination of p minus 1 out of n minus 1. So to try to understand the formula a little bit, we could basically look at this example. So over here, you'd notice that I'm adding two combinations with the same total number of objects. So over here, if this is in fact n, then we'd look at the total number of selections for each. You'd notice that the total number of selections of each, if this is a p, then this is p plus 1. So whenever I'm adding two combinations with the same total number of objects, and where the number of selections differ by 1, in this case, the sum is in fact equal to the combination of where the total number of objects would be 1 plus the original total number of objects, and the number of selections would actually be the greater or the larger number of selections in the sum. So this would be p plus 1, and this would be n plus 1. Now over here in this formula, they were n minus 1, n minus 1. So adding 1 to them, that would give me an n. And over here, p and p minus 1 differ by 1. So the larger number of selections is p. So this is the number of selections for the sum combination. Now, if we were to prove this, of course, for the left-hand side, the combination of p out of n is again n factorial over p factorial into n minus p factorial. Now, over here, we're going to consider these two combinations and add them in order to try to reach this quotient so that we would end up with the combination of p out of n. So the combination of p out of n minus 1 plus the combination of p minus 1 out of n minus 1 is equal to the first one, that's the total number of objects factorial over the number of selections factorial times the difference factorial, so that's n minus 1 minus p factorial, plus, again, the total number of objects factorial, that's n minus 1 factorial, divided by the total number of selections factorial, multiplying the difference of these two, so that's n minus 1 minus into p minus 1. So minus into p minus 1, that's negative p plus 1 factorial, expanding the negative into p minus 1. So over here, that would in fact be n minus 1 factorial over p factorial n minus 1 minus p factorial plus n minus 1 factorial over p factorial, p minus 1 factorial. Now over here, the negative 1 plus 1, they cancel out. I'm left with n minus p factorial. And this is the sum I aim to actually simplify into n factorial over p factorial into n minus 1 factorial. So over here, looking at these two fractions, whenever we have the sum of two fractions, we aim by reducing to the same denominator. So to reduce to the same denominator here, we'd have to actually look for the least common denominator. So if we look at the common factors, now over here I have p factorial and p minus 1 factorial. They're not common factors, but they're factors that involve the same parameter. So over here, p factorial and p minus 1 factorial. Now we know that p factorial is in fact p into p minus 1 times p minus 2 times p minus 3 all the way to 1. So that would be the same as p times p minus 1 factorial. So we notice that p minus 1 factorial is a factor of p factorial. Therefore, in order to end up with p factorial as a least common factor here, we'd have to multiply p minus 1 factorial by p. Consequently, we'd have to multiply the numerator by p. And now looking at the other two factors, we have n minus p and we have n minus 1 minus p. Now n minus 1 minus p, rearranging the terms, is the same as n minus p minus 1. The sum is commutative. So over here, n minus p minus 1 would in fact be 1 less than n minus p. Therefore, n minus p factorial, again, is n minus p into n minus p minus 1 factorial. Similarly to the previous one, it's as if I have 8 factorial, but I'm saying that 8 factorial is the 8 times the factorial of the previous integer. So over here, since n minus p factorial is n minus p times n minus p minus 1 factorial, then over here, n minus p minus 1 factorial would actually turn into n minus p factorial by multiplying it by n minus p, and again for the numerator. So over here, we end up with n minus p into n minus 1 factorial divided by p factorial into. Now n minus p into n minus p minus 1 factorial, that's in fact n minus p factorial, plus p into n minus 1 factorial, that's divided by, now p into p minus 1 factorial, that's p factorial, into n minus p factorial. Now we notice we reached exactly the same denominator, and that denominator is the one we're looking to find. So now all I have to do is just fix the numerator. So I'm going to continue here at the top. So over here, having the same denominator, I can just add the numerators. So that would be n minus p into n minus 1 factorial plus p into n minus 1 factorial divided by the denominator p factorial into n minus p factorial. Now let's just try to rearrange the numerator into n factorial. So over here, you notice we have n minus p into n minus 1 factorial plus p into n minus 1 factorial. So expanding the terms at the numerator. So we'd expand the n into n minus 1 and the negative p into n minus 1 factorial. So that's n into n minus 1 factorial minus p into n minus 1 factorial plus p into n minus 1 factorial divided by p factorial into n minus p factorial. Now these two terms cancel out. We'd be left with n times n minus 1 factorial. That's the same as having 8 times 7 factorial, which is 8 factorial. So n into n minus 1 factorial is n factorial divided by p factorial into n minus p factorial, which is the combination of n out of p, which is what was required to prove. Now, in this quick example, we need to show that this sum is equals to 2 times the combination of 4 out of 11. So we notice that all of these 4 combinations do have 10 as a total number of objects. So over here, in fact, according to the previous property, we need to look for the 2 combinations that whose number of selections differ by 1. So if we look at these two, the number of selections differ by 1, and these two, the number of selections differ by 1. So the combination of 7 out of 10 plus the combination of 10 out of 6 plus the combination of 3 out of 10 and the combination of 4 out of 10 is equals to. We have the first two here where the total number of selections is equal, the total number of objects is equal, and the total number of selections differ by 1. So according to the previous property, in that case, the total number of objects increase by 1, so the 10 becomes an 11. And for the total number of selections, we do take the larger number of selections, which in this case is a 7. And similarly for the other two. For the other two, we have the same number of total, we have the same total number of objects, which is 10, and the total number of selections differ by 1. So for the total number of objects, it increases by 1, so it becomes an 11. And the total number of selections, we do take the bigger one or the larger one. So we do, in fact, take the 4. Now, if we look at what's required to prove, what's required to prove is, in fact, 2 times the combination of 4 out of 11. However, if we look here, we did end up with 1. So we still need the sum of 2 combinations of 4 out of 11 in order to reach the result that we are aiming to prove here. However, if we look at the combination of 7 out of 11, we notice that the difference between 11 and 7 is 4. And we have seen the property, which is the third one, that says that the combination of P out of n, P out of n is equal to the combination of selecting the difference, which is n minus p, out of the n total number of objects. Okay, so over here, basically, since 11 minus 7 is a 4, then according to this property, the combination of 7 out of 4 is equal to the combination of 4 out of 11. I'm sorry, the combination of 7 out of 11 is equal to the combination of 4 out of 11 plus the combination of 4 out of 11. So adding this combination to itself twice leads to 2 times the combination of 4 out of 11.